Okay kids, time for me to drop some content knowledge on your brain. Boom! So you're watching this video, and the words that are coming out of my mouth are going into your ears, and your brain is interpreting them, and you can actually understand what I'm trying to say, at least in theory. We take this for granted most of the time, but if you actually stop and think about all of the things that have to go right in order for that to work, it's mind-boggling. Scientists have learned a lot about the brain in the last few decades, and in fact the 1990s were actually designated the decade of the brain. Scientists have been trying to understand that 3-pound glob of cells that exists in your head and how it makes the rest of life possible. I mean, sure, you need your heart to, live and your lungs to breathe, but in reality, your brain is what makes those things possible. Your brain is made up of billions of cells that form a complex communication system. This system tells your eyes to blink and your heart to beat, and it makes sense of all of those thoughts and feelings that you have. And as adults, we become pretty efficient and well practiced at this whole living thing. But anyone who's experienced life with an infant knows the dirty little secret that at one point, all adults were terrible at everything. I mean, come on, babies. You can't even hold your head up without help. Although you can cry and eat and poop pretty well. And the study of development is about what happens to get us from that tiny wad of cells in a mother's womb to completely sophisticated adults. And that process involves a lot more than the human brain, to be sure, but the brain is really what makes it all possible in the first place. So let's go over some basics. This is a neuron. Okay, well, actually it's a plush toy of a neuron, and I call him Newton because, well, obviously, but you get the idea. Neurons have several different parts. We'll start with Newton's face here, which represents the cell body. This is also sometimes called the soma, and it's where all the typical fancy cell stuff takes place. Newton's little arms here, these are called dendrites, and they're kind of like your mailbox because they collect messages from neighboring neurons. Newton's skinny little body here is called an axon. Now, if a neuron wants to send a signal to another neuron, an electrochemical signal travels across the axon and out through what we call axon terminals. These little axon terminal dudes are kind of like mail carriers. They transmit a message to a neighboring neuron across a gap, which is called a synapse, and they deliver that message into the neighboring neuron's dendrite mailbox. And this process continues to create communication between neurons and across vast networks across the brain. But how do these cells get to where they're supposed to be in the first place? During the prenatal period, before the baby is born, there's a ton of growth and change happening in the brain and the body. And one of the biggest changes is the growth and migration of neurons to their eventual locations. All of this is controlled by very specific chemical signals that tell the neuron where to go and where to stop. But even once they get to the right spot, they have to reach out to their neighbors and figure out if this is really their kind of neighborhood. This process of reaching out is sometimes called synaptogenesis, and it's the process of creating new synapses between neurons. Basically, all the Newtons in the world are reaching out to make friends with everyone in their neighborhood. Hello! Hello! But like in all neighborhoods, you might like some of your neighbors more than others. You might remain in close contact with some of them, but you'll lose touch with some of your other neighbors. And your brain does this too. Through a process called synaptic pruning, your neurons' connections to one another actually die off. And let me stress, this is totally normal. This is not a case of more neurons is better than fewer. In fact, scientists think that synaptic pruning is actually essential for more efficient communication across the brain. This faster and more efficient communication is actually what makes things like language and thought possible. In this case, more synaptic connections don't make you smarter. They actually make you less efficient. But that said, too much synaptic pruning isn't ideal either. In fact, there's some really distressing studies that suggest that children who are exposed to extreme neglect early in their lives actually have smaller brains than their peers. Really, you just want a good balance of experiential learning early in life. So things like crawling or babbling with a caregiver or sticking weird stuff in your mouth, these are all experiences that are helping your brain get organized. Your brain expects it because early in life, your brain is most open and ready for new information to build a solid foundation. It used to be that we assumed that what happened to babies early in their lives didn't matter because they wouldn't remember it anyway. Quite the contrary. These little youngins are actually building the brains that they will use for the rest of their lives. And let me tell you, it is much easier to get it right the first time than it is to fix it later. But we'll get into that in another video. End screen! Thank you for watching. What puzzles you about your brain, and what other topics would you like me to cover? Tell me in comments below. And as another announcement, I'm going to VidCon next week. I'm so excited! So if you're going to be there too, let me know on Twitter. I'd love to meet you.